Hey guys, and welcome to Part 20. This time we are gonna take a look at how we can turn this crazy swayiness into something looking a little bit more like a tree swaying. And let's take a look at this one, for example. So our material we did last time is packed away inside this MF material function, sway, which currently uses simple grass. Now, a tree, a branch, if you watch it in the wind, it will sway kind of back and forth. But it resembles kind of like a sinus curve, but not quite. It's a little bit more, it has a little bit more variation to it. So we're gonna actually just cheat and use two sine waves. And for that, we're just for now gonna get rid of this simple graphs here. And then we are gonna take a look at a node called wind. Now inside this one, we take a look at that. It's actually fairly simple. If you look at what it does, it's doing some masking and doing something with the distance to 0, and this outputs the strength. So closer to 0, 0, 0, it's going to be very little strength, and the further away you get, it's going to be greater. And is something with the normalized vector, I guess, and giving the direction, which we might also take a look at later on. I don't know. I'm not really sure how much further I'm going to take this, because I can basically keep on building on this, and at some point I think I'm going to have to say, okay, this is going to be all right. And yeah. Anyway, the interesting part here is really the wind speed, which just takes something and multiplies by the time. And that's actually just what I'm going to use. So instead of using this, let's say no to that, instead of using this wind node, which is kind of, I don't really need all that stuff, I'm just going to take take the time here, and I'm going to make a sine node, sinus, and plug the time into that, and then that into the multiply. So we now compile this and take a look at how that affects it. We can see that now things are kind of waving a little bit. And this is actually not that bad. So it's kind of a little bit too fast to my taste. So what I'm going to do is to take that sine node here, and I'm going to multiply that by a factor. Which I'm going to call speed. Oops. Let's take 0.5. So cut it in half. And let's give it a comment so we know what this does. So we're basically taking the time, and we are taking that time and breaking that down to half time. So it should be moving quite a bit slower. And already now we can actually see that it starts to look quite a bit like a swaying tree. I don't know how clear this comes out on the video. I mean, I don't think it's looking that bad at all. Actually, I'm pretty satisfied with this. So let's take a look at how, because it's currently just swaying back and forth that direction, just in one direction. We don't have any real control over how it moves or which direction it moves. and that could actually be kind of interesting to do. So in order to just break the what do you call that in English? I don't know, but let's take an initial look at how things can be controlled with the direction and such. So if we just type in wind again, because there was actually something interesting inside this one. We had this node over here, the wind actor, and it actually has a preview value. It's got an x0, y1, and c0, and w1. So this is actually the direction, or x, y, c is the direction. So in this case, it's moving along the y direction. I would think actually no, because it's taking the alpha here. So in order to do something about that, what I'm going to do here is to say the speed here. We also want to multiply that by the 3D vector, or actually it's just a 2D vector. We don't need the, what do you call it, the c-axis. Let's just add a 3D vector. Maybe we want it to go up and down a little bit at a later stage, and then we have it. So let's just use this one. And then call this direction 1. And if we open this one up and say we want this to move like 1 in the x direction and maybe half in the y direction, and not in any way in the c direction for now. And then hook that up. Then we have a setup where we can control the direction. So later on, if you want to do something like an impact or something, this can become quite interesting if you start to affect this with some collision maybe, or I don't know. I haven't really thought this through. But anyway, it's kind of hard to see at this point, but we are now controlling the direction. So let's take all this stuff here and let's just make a copy of that and call this the direction 2 and give them some different numbers. So let's say 0.78 something, 0.6 maybe 7 something. Let's give it, I don't know, like this. And let's give it, I don't know about the speed really. We can either do the same speed or 2 different speeds. So this one would maybe go 0.7 something. But in order to get these two together, we want to add the result of this sine and the result of that sine together, and then multiply that in here. And let's take the stuff here and switch it around for now, like that. That's just to make it a little bit prettier. And actually, now I think I want to switch this something like this. Okay, so let's save that. So what I'm doing here is really just to create a little bit variation to this. So hopefully we can see that now it's not just moving in a constant back and forth, it has a little bit of variation. Which is kind of cool. Okay. And in order to control the how much we want this to sway. Once we add this together, we could add another multiplier at the end here. So say we want to multiply whatever we get out of this with a scalar value of something like, let's say, something ridiculously high as 5 and strength. I'm just giving it a name, basically. Okay. So that way we can also control how much it sways. So there's a lot of room for improvement here and tweaking and experimentation, really. So I'm just showing the techniques I'm trying out here. So let's do something about this stuff here. I'm not really happy about the stuff going on here. So the reason for this intersection and moving around is because I have these vertex weights or painted on, and they are all based on basically the width of the stem. And since I want them to grow progressively smaller or thinner, but when I do a branch, I want the sub-branch to start at one step smaller. Then there's going to be a difference between that point where the branch is going to go off and over to the beginning of the next new branch. And that's going to be smaller. So that's why there's a deviation here causing it to float around. So I decided to actually do a different set of calculations for this. And the way I'm going to go about that is I have thought about this, actually woke up this morning and I had an idea and I thought, okay, I think I'm going to do this. This is probably going to be a little weird, but I'm going to do it anyway, and maybe there's a different way, because I actually had a few ideas and then but ended up discarding them. Blah blah. Yes. So the idea I came up with was to add a new variable called max distance. Spline point. Ah, fuck, that's a long name. Spline point dist. And that's going to be a float. And that I'm going to be setting every time I add a new segment. And what I'm going to do is to use the fact that I work in relative space. So the base of my tree is going to be at 0, 0, 0. And my relative transform here is going to move from that point upwards or in a certain direction. So the distance, the further away we get, is going to get bigger and bigger. So I'm just going to set, basically just compare this value, the distance for the turtle's relative point inside the add segment, and then figure out how far away we are. And if we are further away than the current max spline dist, which is going to be 0 to begin with, then it's going to just replace that. So I'm going to take the location, and I can use just the location. I don't need to subtract anything from it, because as mentioned, this is going to be starting off at 0, 0, 0. So I can just do a vector length. And then I'm going to compare this and say if this is greater than the current, then I'm going to do a branch, and then I'm going to replace it with that value. So I'm going to set this to be equal to that vector length there. Okay. might want to comment this stuff here because it's kind of new stuff here. So let's say, what do? We get find max spline point distance. Okay, and we want to make sure to set this to 0 when we initialize this. Let's see, we have the construction script. We call initialize tree, we call generate tree, and if we don't have freeze branches, then we want to set this to 0. Okay. So that means it's going to start off at 0. If we freeze the branches, then it's not going to be reset. Then we're just going to, that will allow us to adjust things without having to to have a tree configuration and then tweak this, whatever we need to do. Okay, so now we have that set up. And that means that we can tweak a little bit on our scale setup here. We have here. I am gonna, because yeah, the thing is, I set the local start and end, and I do it both here and here, and now I need to add more of this logic, and it's basically the same. And for now, it was okay to do this, but I think this is a good time to move things to the side and then create some local variables to hold this. So let's take this and hold all the way down here. And then promote this to a local variable and promote this one to a local variable. And let's call this the local start vertex color. And this one for the local end color. Let's call it vert, so we don't get too long names. So we want to set this one, and we also want to set that one. Okay, so that wasn't that bad actually. Maybe that was a little bit too much space. Anyway, doesn't matter. Or maybe I need more space anyway, because I need to add some stuff here. Okay, so we still need the start and end scale. We definitely need it because if we are using a spline thicken material, then we want to use the red channel for that. So I'm gonna put some stuff into the green channel this time here. And what I'm gonna do is to calculate the distance also here. So I have my start point, that's here. I saved that previously. And I also have my endpoint. So these local start and end point, those are the values we get here. So they're going to tell us how far away from the 0, 0, 0 we are. And we're just going to do this calculation in here. So we're going to set length vector, length of this one. Let's just, for now, get the vector length. And we can plug that into the green channel. Let's see. Yes. And we can do something similar down here. Plug that in here. And for now it looks okay. Let's see, I have a feeling I'm missing something. Oh yeah, since these values are going to be used for vertex paint, and the vertex paint can't take values over 1, it has to be a value between 1 and 0. Sadly, I asked on the answer hub if it was possible to allow that, because I have some good ideas for this, how we could use that if it was allowing higher values. I tried and it didn't work. It does work. Well, you can input them, but it's not going to work when you then apply the vertex paint. It's not going to apply higher values. So it doesn't work like an emissive color, for example, which is kind of a shame, really. Anyway, so I need to normalize this, and that's why my max blind point distance comes in. Yeah, so I'm going to drag this in, and then I'm going to say normalize this to range from 0 to that point, that distance that we got. And then we can hook that one up. We actually need to do something similar down here. Value this, and this. Okay. So all the way at the end, we set the vertex paint for the leaves. So instead of replicating that, we can just now take our two vertex start color and end color and plop them in here like that. And then we have a nice simple setup for that at the end here. So if we now compile this and save, we don't see any difference because we didn't change the color that we need use. So we now take the green color instead. We can now see it's staying completely on spot. But now the basement is the base of the tree is moving, and if we move all the way up to the top, we can see the top is standing still. So we don't need this because it's inverted. So yeah, just need to do this. Okay, so this looks pretty good to me. One more thing I want to add before I end this video is a way to control how far up this starts to sway, because with a tree like this one, this looks still really odd, I would say. And even though the material itself right now is a multiplier of 5, and we don't have a way of really altering that unless we go into the material itself. That's something I'm going to take a look at later on. For now, I'm just going to set this back to something like maybe just, well, I think I'm going to set it to 1 so we don't multiply anything to this at all. But as you can see, still, I've just came home actually from the woods, and I was having a walk with my girlfriend, and we were watching the trees, and I was noticing that these kind of trees don't sway that much on the basement, definitely not. So I decided actually to add a little parameter for this also. So let's add a variable in here, which we will call branch sway offset or something. Used to set how far up zero equals no and 1 means no sway. Okay, and we want to make this, oh shit, I made it a local variable, damn it. I made all this nice comment and I screwed it up. What did I call it? Branch sway offset? Or was it branch offset sway? I can't remember. And I typed in something like, so fuck, I can't remember what I wrote. Used to control how sway begins. 0 means no offset. 1 means no sway. I'm pretty sure I had a better comment last time. Anyway, I really have the memory of a goldfish sometimes. Okay, so what I'm going to do here is to take my branch sway offset, and I'm going to insert the thing here. So we normalize this, and then I want to subtract my branch sway offset from this. And I want to do that both for the start and the end. Yes. So let's see. So right now we don't have any sway offset on the tree here. So if we scroll down, we can set like 1, and then it doesn't sway at all. And if we say 0.1, then we can see the basement here, or the base, is completely stationary, and then it starts to sway from here on. Yeah, I still haven't figured out a good way to make this transition a little bit smoother. I'm pretty sure it's kind of trivial, but I couldn't really get my head around the math for this. I'm just gonna check something maybe here, over here. Okay, it looks pretty good. We don't have any weird sliding around stuff going on. Oh, it's just me getting seasick. Okay, and if we look down here, it does have a little bit of, oh, because I didn't set anything for this one. Let's set something like 0.4 for this one. And then it looks pretty solid at the base here, and if we just look at it further up, we can see that it's actually moving around. So that's pretty cool. Now here's the thing I haven't really figured out. If I freeze this tree, let's say I'm really satisfied with this. Notice when I move it around, the branches are still gonna randomize, but the tree itself is gonna be fixed in that position. So if I set this to say 0, I would expect it to start swaying, but it doesn't. Because I think, and I haven't really figured out how to come around that, because my max spline point dist is, every time I compile this, it defaults to this max spline 0 value I have here. I can't really figure out how to get rid of that default value. But if I, for some reason, set this to be public, like this, and I'm gonna, for now, actually, I'm just gonna put it on the branch so we can see it easily. Maybe somebody can tell me what I'm missing here, because I'm pretty sure this gotta be something trivial. We can see it has branch sway offset. I need to compile this. Yeah. Oh. Yeah, max blind point distance. So right now it says 0. And if I what? If I compile this, huh. What? Okay, so it's just stays like that. Okay, so anyway, if I unfreeze this and move it around, we should see that it's constantly changing. If I freeze my branches now, we can see it's still swaying. We can move it around, but the height doesn't change anymore. If I now change this to 1, then the branch itself is completely fixated. Oops. Which is what we wanted. And I can also set this to, let's say, something like 0.23. And then it's gonna sway a little bit further up, which is what I want. But if I, for some reason, if I make this non-public, compile that, then since it's let's unfreeze it again. So now it's looking okay. I can set it to sway all the way from the back up, from the bottom here. Set it to 1, and it's gonna update accordingly. But if I freeze this now, and I set it to 0, it's not gonna do anything. I don't understand. I really, really don't understand. So I only set my max blind point to 0, and I figured out that this is set, for some reason, being set to 0, no matter what, but this code is not being run. You can see it's not hitting this part here. Whoops. So yeah, kind of weird. Anyway, I wanted actually this to be a short video, but as usual, I end up talking too much. So I'm gonna call it for now, and I'm gonna take a look at one last tweak to this in the next video, which revolves around what we do when we want to convert a lot of trees into static meshes and reuse them with several of these, maybe even with the foliage tool and so on. So that's also going to have some problems with the current setup. But yeah, stay tuned for that, and see you in the next. Bye bye.